Hello, in this short tutorial I will show you how to calculate online pair radial distribution functions from your crystal structures or from LAMMPS Trajectories files. To do that we will use a program which is called XRDlicious, developed by our implant team, and it is available on the link. If you write thisname.com it will take you to this app. Okay, so let's start directly how to use it. First of all, I need to select from the sidebar which calculation type I want to do. The module or this program has currently more modules, and we need to do the pair radial distribution function analysis. This diffraction calculation we don't need, so I can close it. And you can already see the settings for the PRDF. And now I need to upload my structure files, which can be either in CIF or POSCAR format from VASP, XSF format, PW, or also LMP or data format from LAMMPS. And if you don't have your crystal structure files, you can search for them using implemented search interface for three databases: Materials Project, AFlow, or Crystallographic Open Database. So let's just illustrate it on an example, searching for structures which contains these three elements. I can simply click here, and it will take a few seconds before all the search is finished. Okay, and once it's done, you can list through the found structures and select the one that you want to add to this calculator. So for instance, I want to find cubic strontium titanate, this one, and I can add it to this program, and you can see it was added here. If I want to delete the structure, I can click on this cross. If you have your files, you can upload them by clicking here and selecting the structure that you want to on which you want to calculate the PRDF. For instance, I can select this alpha titanium, and you can visualize the structure immediately with this structure modification or visualization tool, which I left on, and I can switch between the structures, and you can see how the face looks like. And you can also, if you need, you can perform some basic modification of this structure. Okay, so this tool we don't need now. I can simply close it, and let's just keep this strontium titanate here. So I will remove this alpha titanium. Okay, so the settings is just the cutoff distance up to which the PRDFs should be calculated, and the bin size. I can reduce it now like this, and if I click to calculate, it will compute the pair radial distribution functions from each element combination, and at the end there is the total radial distribution function. These data I can download. If I click on this button, it will prepare every file for download, and I can obtain it if I need. If you upload more files at once, it will, if the same elements are in these more structure files, it will compute the average pair radial distribution function for that element combination. So if you need to just analyze one structure file at a time, just upload one structure. This will just remove this point from the graph if I don't need it. Okay, so now the other option is to upload LAMMPS Trajectories files. And important note is that we are currently hosted on free Streamlit community cloud service, which has a RAM memory limit up to 2.6 gigabytes. So I would recommend not to uploading larger files than 100 megabytes, and also not to have many sample frames inside a file. If you need right now to analyze larger files with larger amount of frames, you can compile this XRDlicious application locally on your computer and increase the limit size for this uploader, and you can use it as you need. And if we find out that there is a need to improve performance and increase this limit size, we will upgrade to the paid server, which will allow us to use more resources. Okay, so I will illustrate example of my trajectory, which is just aluminium with increasing temperature. So I will upload it here, and it was very quick because I'm using the app on local computer. And this parameter is like every frame I want to include in the PRDF calculation. So if I put 1, it will include all frames which are in the uploaded file. And then there are two modes. One is the total average PRDF across all considered frames, and then it's the individual frame which contains PRDFs for each time step or each considered frame. And this will allow me to play animation and see directly how the PRDFs changing with simulation time. Okay, so just for illustration purposes, to quickly finish the calculation, I will use frame sampling 100, and now I can run it. Now it's trying to read this LAMMPS trajectory file, and you can see it was successful, and then it performs the PRDF's calculations again for each element combination. In my case there will be only one for aluminium. If you consider more frames or lower sampling rate, it will take more time. And you can see the result if I put back this average PRDF across frames. So it looks like this. I can make it full screen if I want. And the second mode, individual frame, here I can play an animation. Let me make it full screen first, and I can see how my RDF changing with time or with increasing temperature. If I select auto scale here, it will look much better. I can zoom out. So the thing that I can immediately see is that my structure is changing from well-defined crystal phase to amorphous phase, where all these local peaks disappeared, well-defined peaks disappeared. Okay. In the second mode, if I need, I can change the animation speed with this button, so now it will be slower. Yeah. Again, I can put auto scale. Okay, and as before, I can remove the points from the plot if I don't want them there. So that is all how to calculate online pair radial distribution function from your crystal structure files or LAMMPS trajectory files, and hopefully this tool will be useful for your purposes, and thank you for your attention.